Let's talk about orthographic projections and the role they play in engineering drawings. Typically, when you have a 3D object and you want to display it on a piece of paper, you're going to have to, in some way, shape, or form, skew your object because you can't get the curvatures depicted on a flat surface. So the best we can do is kind of think about it as in terms of a cube, and that if we had our object inside of the cube and shined light through it, what would you see on the different sides of the cube? And with those orthographic projections, we can get a pretty good detail of the height, width, and depth, and ultimately describe the dimensions needed to build our object in 3D. So let's think about it, visualize it with a piece of paper. So grab a piece of paper, I want you to fold the piece of paper in half, unfold it, fold it in half the other direction, unfold it, grab this top northeast corner, we're going to fold it from the center down to where those adjoining views will meet. Increase that corner right there so we kind of form a box. So what we're looking at with our drawing is that we're going to have a front view, a top view, and a side view. And together those three views are going to form, from the front it's going to be the width and height, from the side is going to be the height and depth, from the top is going to be the width and depth. And so you can see that on the adjacent views for the side and the top, that you'll actually have the depth measurements going kind of across this void where you'll see them on those views that don't necessarily meet unless you folded them together. So then if you look at your object from this focal point, this is kind of the isometric orientation that you would see your object from, equally skewed in all directions, about 120 degrees. So if you unfold it, our isometric view is going to go right here, oriented in that direction for what you would see if you folded your orthographic projections. Typically, most of our drawings we can depict using those four orthographic views, the top, front, and right side, and are isometric. You can add a left side view and a bottom view if it is needed in order to add extra clarity to our object. If you have redundant views, you don't really want to include those. So if you have something that's cylindrical and your front view looks just like your side view, you don't have to include your side view. You will always need to include your front view. When you're including dimensions, every feature needs to be fully defined in terms of size and location and shape. So you're going to show the shape with your drawing, but your dimensions is what's going to show your size and location. For our assembly drawings, once we have our part drawings, those have all of our dimensions on it. So our assembly drawings do not include dimensions. All we're doing there is showing how our object is created by forming our different parts and assembling them together.